Good afternoon. My name is Ashish Kumar. I'm the Managing Director of Verbio India. Verbio is basically a German biofuel producer. We have just recently set up, commissioned Asia's largest biomethanation unit. It's in Punjab, district Sangrur. What I'm going to share with you is just a couple of pictures so that you get an impression of what scale of operations we are dealing with. Doesn't work. I mean, this is the picture normally you're probably familiar with, and Delhi will experience it again after 2 months. The whole issue of stubble burning. This is what it looks like. Uh, uh, can we? Yeah. So, on an average, the state of Punjab generates roughly about 20 to 25 million metric tons of stubble per year, which is getting mostly burnt, right? And this is what you end up seeing. Uh, okay, next. Which ends up generating huge amount of these greenhouse gases. Uh, Next. So this is what we are doing. So instead of those farms being set on fire, we are doing what is called as XC2 management. All this agri residue is getting baled, collected. The uniqueness about what Verbio does is the complete value chain is integrated, which means the entire stubble collection, all the machinery, the labor which is required to collect this stubble in that limited period of about 45 days post harvesting of paddy is done by us. We are not relying on a third party. So that means, and that applies to anybody in this waste to energy kind of a business sector. Unless we do not have control over the raw material, we are going to be extremely dependent, and that is a huge risk as far as the overall business operations are concerned. The plant has a capacity of producing about 33 tons of bio CNG per day. We consume 1 lakh tons of stubble or agri waste in a year. This is how the waste looks like. What you see, the dots over there, these are called bales, and the weight of each bale is roughly about 400 kilograms. So these are not as small as they look on this chart. Typically, what you see in India are these small bales. Small bales means roughly about 20 kilograms. Now, if we convert 20 kilograms into the kind of operations we have, we need an army of people to manage that kind of volume. So that's why we upgraded the scale. We moved from 20 to 200, and then last year we moved to 400 to 420 kilograms of each bale. This is how the waste is getting collected. Now, it is very different from how I've been hearing since morning, because typically when we use the term solid waste, we end up talking only about MSW. We do not talk about agri, we do not talk about industrial, we do not talk about hazardous. I mean, this is, I'm not saying that MSW is not important. MSW gets a lot of attention because it's all the year round. This is I call it the festive waste. People start talking about it around Diwali and forget it around Christmas, right? So this is typically what happens in India. So can we go to the next? These are all our machines. These are the tractors, balers, where the entire complete supply chain in terms of collection of this agri waste is concerned, is being implemented. All these machinery are not, they are all imported. Not because we like importing, it is because they are not made in India. There is no supplier which can make these kind of machinery in India. So we have no option but to import it, which means import taxes, which means taxes, import duties. Again, the viability of setting up an value chain or a supply chain becomes extremely expensive, and somehow there is zero importance given to if a corporate does it. If a farmer does it, he gets subsidy. If a corporate does it, he gets nothing. I'm solving the same problem. what a farmer is expected to solve, but let's appreciate that a farmer cannot invest to this scale. The one set of machinery, what you're seeing over here, that's a set of roughly about 70 lakhs. And this is still mid-scale. We can go even higher, which means one set of tractor and a baler could be roughly about 1.2 crores. That is the cost of one set. And I'm not talking about all the machinery which is needed before this step and after this step. Can we go to the next? This is the other set of machinery. What you need, what you see on the left top is a raker. The rows which you saw, right, as to how the entire waste which is spread over the farm, that needs to be brought together. That is done by this machine. It's a raker. Then comes the baler over there. Then after they are baled, you need loaders to pick those bales on the trolley. Then you need the trolleys for the transportation. And that's when it goes to a storage location. So this complete value chain has been implemented by us over the last 3 years. We had zero experience in implementing this in India. And yes, we did talk about some companies who are doing it. But let's understand, for me, this is a cost. For those companies, it's a revenue. For those aggregators, it's a revenue. So he wants to maximize his revenue. I want to minimize my cost. There's a conflict of interest. So the aggregator model is not a good model as far as the biofuel is concerned. The reason being, the end product is bio-CNG, CNG price. The CNG price is fixed. I have no influence over that. So I can only have influence on my cost structure. So I have no option but to do it on my own. That is one. Cost is one major reason. The second reason is the quality. There is zero orientation towards quality of feedstock, which basically means moisture. Moisture has to be low. If it is wet, then it is of no use. Now, I do appreciate that it's a new sector, it's in its nascency, but still there are not really many players who are able to crack it so far. So this complete value chain, what you see, how neatly are those tagged, right? So it's not getting burnt, but it needs to be stored systematically. It needs to be protected. Can I have the next slide, please? This is how we store it. Yeah? So this is the way the raw material needs to be protected. Why? Because my harvest happens once in a year for paddy, which means if I have to collect 1 lakh tons of feedstock in a year, I have to store it for 10 months. Because my production is running 24/7, 365 days. It needs to be fed on a daily basis. The plant cannot be lying shut because there is no feedstock, which means you need to create a kind of a hub and spoke model wherein there are storage locations which is feeding the production unit. We have to protect it from two culprits, fire and water. And these are the toughest ones to handle. Right now, water, monsoon, which means it looks quite simple, and that's how it should be, but you will see it's sitting on a raised platform. I cannot put it on the ground because the moisture from the ground will come in, which means an investment, right? So this complete storage infrastructure needs to be created, for which at the moment we get zero support from anybody. No center, no state, nothing. It's all done on our own. Yes, we are doing it as a pilot case to demonstrate that yes, there is a technology which can convert stubble into an automotive grade fuel. We have demonstrated that. We are already producing about 6 to 8 tons of gas per day. When I say automotive grade fuel, I'm talking about 96% plus methane. CNG normally has 90% plus. Can we have the next? This is the plant. This is spread over 20 acres. What you see over there are the 8 digester tanks. So I was asked, how do we do it? It goes through an anaerobic digestion process. So basically what we do is replicate what happens in the stomach of a cow. That's simply what we do, right? Those tanks have got water, straw, and bacteria. That's it, right? But yes, it's all done in extremely controlled conditions. There is a huge process behind it. So we feed him. You see a lot of feedstock lying over there. It is that shed to the right is the pre-treatment part. Before eating, we chew it. So those are my teeth. So it needs to be chopped in very, very fine powder. Powder means 3 to 4 mm. This is the length of my straw. Now imagine that being diminished to 3 to 4 mm. And that's when it is ready to be fed into the tanks. And then we have the most loyal employees, the bacteria, coming into play. They do their job. We have to maintain the temperature conditions, and that's when they work. If it gets too hot, they don't work. If it gets too cold, it doesn't work. So the ideal temperature conditions is, let's say, roughly about 37 degrees plus minus. That's the temperature which is needed for this fuel to be produced. The fuel is raw biogas. Raw means anything around 45 to 50% of methane, which cannot be used for any industrial or automotive application. Then it goes to the left. That is where the purification happens. That is where we get rid of the carbon dioxide, and the methane level is spiked up from 45-50% to 90 plus. And then it is ready to be transported. Can we have the next? This is how it is transported. So this is our own fleet of trucks, our fleet of cascades, wherein we compress the gas, we dispense it, and then it goes to the retail outlets of Indian Oil. That's what we do. This is the first pilot project of Verbio in India, in Asia, and this is the largest so far. Coming to why we are here, of course, I thought I'll take the opportunity to introduce the project to you. The second is, of course, this project comes with a huge amount of financing demand, right? This project is an investment of roughly about 240 crores. It's all equity, zero debt. Not because we have a lot of money, it is just that 3 years back, there was nobody who was willing to appreciate what this is. The only thing what we got is a long list of risks and how it cannot be supported. So we thought either we can wait and watch or do something about it. Then we decided, okay, one plant we will set up. We'll demonstrate that it can be done. And now we are looking at expanding. So a business like this needs 3 revenue streams. One from the gas, which is working well. The second from the manure. Let's go back to the cow's stomach. That generates 2 things, gas and manure. The gas is monetized, the manure is not. And the third revenue stream has got to come from carbon credits, which is not existent at the moment. I've been hearing that we'll have a Azadi Ka Amrit Mahotsav celebration another 2 days, and some announcements are going to be made. Let's see what's in store. So these are the 3 revenue streams which you need for this business case to be viable. We are looking at setting up 10 units in the next 3 years in the states of Haryana, Punjab, Uttar Pradesh. This is where this problem is. So what we are looking for is one simple word, green financing. We're not looking for loans, grants, no mercy. We are just looking for green financing. We are not looking for 7, 8, 9% kind of cost of capital. Such business cases cannot absorb that kind of cost of finance. If my gas is selling at 100 or 120 rupees, yes, we can, but that's not the case. It can absorb if there are carbon credits we don't have. So till such time that these revenue streams are getting more structured and getting implemented, we have to rely on an attractive low-cost green financing, which means 1, 2, 3%. When there are interest subvention schemes existing in India, it's not that we are asking it for the first time. They're existing. They're existing for ethanol projects, for example. Why not extend it to such projects also? There is a huge socio-economic benefit which such kind of projects lead to in terms of employment, in terms of tax generation, in terms of environmental impact. A plant like this on full capacity reduces 150,000 metric tons of CO2 emissions. So that's about it. Thank you very much.